Okay, let us solve one problem concerning uniformly accelerated motion. The problem says a car moving along a straight road accelerates at 5 meters per second square, starting from an initial velocity of 20 meters per second. 1. What is the velocity of the car after 5 seconds? 2. What is the displacement of the car after 5 seconds? So let us start from 1. Before we start solving the problem, let us see the given quantities. 1. Acceleration is given. The acceleration is 5 meters per second square, which is positive. And again, the initial velocity is given, which is 20 meters per second. So in order to solve the first problem, we know that an equation which says acceleration is the time rate of change of velocity. After rearranging this equation or solving for dv, we can write it is a dt. So integrating both sides, velocity is integrated from initial velocity to final velocity v of t, and the time is from 0 to t. So when we integrate dv, it is v of t minus v of 0, which is u. And on the right hand side, when we integrate a dt, a is constant, so a dt is t. Our limit of integration is from 0 to t. So when we solve it for u v of t, or before that, let us substitute the value of t, a times t minus 0, which is simply 80. So the result will be v of t is equal to u plus 80. Let I write it again. V of t is u plus 80. We know that a is 5 meters per second square and initial velocity is 20 meters per second. So at any time t, the velocity is 20 meters per second plus a is 5 meters per second, or simply we can say 5t, or let us write it 20 plus 5t, where velocity is in meter per second. So the first question says, what is the velocity of the car after 5 seconds? So when we substitute the value of t, v of 5 is 20 plus 5 times after 5 seconds, 5 times 5, which is 25, which gives us 45 meters per second. So the final velocity or velocity after 5 seconds is v of 5 seconds is equal to 45 meters per second. Let us come to the second problem. The second problem says, what is the displacement of the car after 5 seconds? Already we have got the velocity as a function of time, which is 20 meters per second plus 5t. And we know that velocity is the time rate of change of position. So for the second problem, we know velocity is dx dt in one-dimensional motion. After rearranging this, dx is equal to v dt. V is already given here. It is V is 20 plus 5t. So when we solve or when we integrate dx, which is equal to v dt on this side from initial time 0 to t, and on this side from initial position x naught initial position to x of t. So the result, when we integrate this, the result will be x of t minus x naught, which is equal to v is now, it's not constant. How much is it? It is given over here, 20 plus 5t. 20 plus 5t. 20 plus 5t dt. So when we integrate it from initial time to 0 to t, the result will be 20t plus 5t squared over 2. Our limit of integration is from 0 to t. So the result will be x of t minus x naught, or simply we can say delta x of t after time t, or s of t, is equal to 20t plus 5 over 2t squared. Remember, our limit of integration for time is from 0 to t, and the final time is given over here, which is 5 seconds. So I can integrate, or I can substitute these values. 5. Therefore, the displacement s of 5 seconds is equal to 20 times 5 plus 5 over 2 times 5 squared, which is 25, which is equal to 100 plus 5 times 25, which is 100, which is 5 times 5 is 5, 25, 5 times 2 is 100, plus 2, 125 over 2, which is equal to 100 plus 62.5. So the final result is equal to 162.5 meter. That is the solution.